Hi all. Next topic is about block diagram. Block diagram is the pictorial representation of a control system. By using block diagram reduction technique, we can find the overall transfer function of a control system. The first step in the control system analysis and design is to formulate a mathematical model and then to find the transfer function. So using block diagram reduction technique, we can find the overall transfer function of a control system. Basic elements are summing point, takeoff point, and block. Arrows indicate the direction of flow of signals. Arrows indicate the direction of flow of signals. Now what is a block? The transfer function of a component is represented by a block. It has a single input and single output. Here the input is denoted by the letter X of S and output is Y of S. The transfer function is G of S. Therefore, the transfer function G of S is equal to ratio of Laplace transform of the output and the Laplace transform of the input. So, transfer function G of S is equal to Y of S by X of S. Now, what is summing point? Summing point, it is represented with a circle having cross inside it. It has two or more inputs and a single output. It performs the summation or subtraction or the combination of summation and subtraction of the inputs based on the polarity of the inputs. Here it is y is equal to a plus b. Here it is a minus b. Y is equal to a minus b. Here y is equal to a plus b minus c. Now what is takeoff point? From the takeoff point, we can give the same input to more than one blocks. The takeoff point is a point from which the same input signal can be passed through more than one branch. That means with the help of takeoff point, we can apply the same input into one or more blocks or summing point. Here, the same value is given to the summing point. In the following figure, the takeoff point is used to connect the output CS as one of the inputs to the summing point. So that is takeoff point. This point is the takeoff point. Now we have to apply some rules in order to find the overall transfer function of a control system. First we have to study some rules. What are the rules? First one is summing points can be interchanged. In a complicated block diagram, we can interchange the summing points in order to find the overall transfer function. The summing point is represented with a circle. Okay. So in this example, in this figure, here R of S is the input. Here X of S. R of S and X of S are the inputs to the summing point. So the output is R of S plus X of S. Here the input is, here sign is minus Y of S. So R of S plus X of S minus Y of S. And here it is R of S. Here we are interchanging the summing point. So R of S minus Y of S plus X of S, both are equal. So summing points can be interchanged. That is one rule. Now next rule is about series connection. It is also called cascade connection. So here two blocks G1 of S and G2 of S, they are connected in series. So in this case, what we have to do is, now we know that g1 of s is equal to z of s by x of s, and g2 of s is equal to y of s by z of s. That is according to definition of Laplace, definition of transfer function. Transfer function is the ratio of Laplace transform of the output by input. So g1 of s is equal to z of s by x of s, and g2 of s is equal to y of s by z of s. Therefore, y of s by x of s, that means z of s by x of s into y of s by z of s. Z of s, it will get cancelled, and y of s by x of s, that's equal to g1 of s into g2 of s. So the transfer function of this single block is the product of the transfer function of individual block. The equivalent block diagram is shown below. That is g1 of s into g2 of s, product of the transfer function. So we can simplify these in this way. Two blocks by a single block. Take the product if these two blocks are connected in series. Similarly, if there is n blocks, then the transfer function of this single block is the product of the transfer function of all those n blocks. So that's about series connection. Next, parallel connection. Here, the same input is given to two blocks. They are connected in parallel. So here y of s is equal to y of s plus y2 of s, summing point. So y of s is equal to y of s plus y2 of s. Now what is y1 of s? Actually g1 of s transfer function is equal to y1 of s by x of s. So y1 of s is equal to g1 of s into x of s. Similarly, y2 of s is equal to x of s. Again g2 of s into x of s. So y of s is equal to, take this instead of y1, write g1 of s x of s, plus instead of y2, write g2 of s x of s. Now take x of s outside. That means then take the ratio y of s by x of s. Y of s by x of s, that's equal to, that is the transfer function y of s by x of s, that is the single transfer function, that's equal to g1 of s plus g2 of s. So here also we can represent the parallel connection of two blocks with a single block. What will be the transfer function of this single block? That is the sum of the transfer function of these individual blocks. If it is connected in series, the transfer function of the single block is the product of individual transfer function. Here, when they are connected in parallel, the transfer function of the single block is the sum of the individual transfer function. Similarly, if there are n blocks, then the transfer function of this single block is the algebraic sum of the transfer function of all these n blocks. Some more rules are there. We can study the remaining rules in the next class. Thank you.